Okay, so in previous video, we have noticed the signaling thing and all this differentiation process of few distinct cells. So from that concept, we have come into the stem cell concept, right? So stem cells are some type of cell, are a distinct or specific type of cell that actually can produce different type of cells that are required to produce a formation of the body, like the cardiac cells, enterocytes, fat cells, epithelial cells, neurons, all these cells. So these cells are actually coming from what? In the initial phase, you can just recall that in the blastula stage, here is a picture of a blastula. There are few the cells of this blastula are called the blastocysts, right? So this blastocyst has the potential, or they are efficient enough to produce different type of cells, as they are the initial cells that are they are the initial cells that the initial phase of life has actually produced. So these cells has the potency to produce all the cells that are required to produce the three germ layers of the embryo, the ectoderm, endoderm and mesoderm. And these ectodermal, mesodermal and ectodermal, mesodermal and endodermal tissue layers, as you know, they are actually efficient to produce all the different organs of our body, like the heart, like the blood cells, like all the other cells. So these cells, these initial blastocysts, are actually producing different type of cell, and with that what happens is blastocysts are not in the not they are not dividing. It's not like that. They're dividing with time. They're producing similar type of cell that they were before, but with that also they're producing a differentiated type of cell. So the stem cells has a interesting potential or interesting capability that the other normal adult body cells, the body cells that are present in the mature or adult body, don't have. What are those? They have actually two potentials, two characteristics. So we can, if we can try to classify the characteristics, we try to describe the characteristics, we can describe it in two ways. One is the self renewal capacity and other is the differentiation capacity. So in self renewal capacity or self renewal characteristics, what happens? They actually renew themselves, they renew their previous form. So in self renewal process, they are producing the similar type of stem cells, the similar kind of cell. You can see in the left side, the similar type of two cells is being produced. Okay, after one division, two cells are produced, but on the left side, the cell that is similar in type or similar in shape and similar in size with the previous or the parental stem cell. So this is the process of self renewal. When you know about the renewal process, we renew some our courses. In this case also, the self renewal process is one of the capacity of the stem cells, what actually all the normal body cells actually possess. With that, the difference here is the differentiation. So they are producing the similar type of cell, but with that they are actually producing the different type of cell. That is a specialized cell. That is, they can provide different cells to produce different various organs, but they cannot self renew. This differentiated cell, they will not become the stem cell. They are just the they are just the renewed differentiated cell. They are not the stem cells, and they are actually programmed to die at a we know that our body cells, they are the result of the cell division from the previous one, and eventually they become they die by apoptosis or necrosis and all the cell death processes. But what happens in stem cells? The stem cells are immortal, and one thing is here, that these are quiescent in nature. Quiescent means when they are not getting any signal or something, they are not actually in the active state, or they don't have to divide. But if there is a necessity in the body to produce, for say, there is we have deficiency in WBC, for say, so our body or our blood need WBC. So there are few stem cells are present in our body that are quiescent in nature normally, but when they feel, when they have the signal from the outside blood cells and all these things that I need to produce WBC, then this quiescent stem cell will start to divide, and they will produce one stem cell for itself and one WBC. So in this way, you will compensate the deficiency of WBC in the body. So keep this in mind that stem cells are very important in producing two different um, they have these two important characteristics, that is self renewal capacity and one is the differentiation. So I am just specifying on that, that broadly we can classify the stem cells in two separate classes. One is the embryonic stem cell and another one is the adult stem cell. In embryonic stem cell, what we can say, that at initially when the zygote is formed and that zygote start dividing, after 3 days they may produce 150 to 300 cells. So these cells are a association cell mass, but yet they are not implanted in the uterus, right? So before implanting on the uterus, when they are in the embryonic stage, but all these cells has the capacity of differentiating into other type of cells. So these are stem cells, but they are in the embryonic, they are part of the embryonic association. So when these cells, you can say for the totipotent cells, what we will discuss later, these totipotent cells will, well, they can produce all the type of germ layers like the ectoderm, endoderm, and mesoderm. So they are producing all the type of required cells to produce these germ layers, but they are not the part of a mature body or an adult body. So these are the embryonic cell when they are a part of the embryonic system. And what are the adult stem cells? I just gave an example of the blood stem cell, right? So the mesenchymal stem cell or the stem cells that are residing on the bone marrow. These cells, they are the part of the mature adult body, and they actually differentiate or different or divide when the adult body actually needs. The stem cells are undifferentiated cells that reside among differentiated cells in a tissue or organ, like for say a fat stem cell or fat tissue. So this stem cell is residing within among all the differentiated that are already differentiated into the fat linkage, right? They are already have differentiated into that path, but they're residing inside them, among them. But when they need, the body need, the cell starts dividing and they produce the fat tissue, or they help to produce the fat tissue. So these are the adult stem cells. So broadly we can classify these embryonic stem cells and adult stem cells in these two method. And there are a few further difference classification of the stem cells on the basis of their potency. So we will know about that in the next video.